Today I'm gonna show the same coil I showed in the previous video, but this time I have two identical coils, one on each side of the rotor. They are hooked up in parallel. It is the same 48 pole rotor. The drive system is the same, the pulley ratios are all the same, and I'm driving the system on 20 volt DC at 900 milliamps. In the previous video, when I was driving it with one coil only, I had on this input around 2100 RPM, and now with two coils I have 1890 RPM. So the second core is definitely putting more drag on the system. Let me modify my information here. 1890 RPM open coil. I am gonna do a 1 watt AC load. These coils, there it is. My light holders finally came in the postage today, and that is nice. There's a light. This is 1 watt load AC. Checking what the RPM is doing. RPM is now at 1965 and climbing pretty fast. So yes, that is good. And if you come over here, the milliamps went from 900 to 850. So these two coils are helping my drive side. This is my drive side, this part over here. So here I'm gonna put oh, let me check it one more time. RPM is now 1986. Now I'm gonna go for the 9 watt AC load. 1 watt gives me 1986. If I remember that right, yes. These 9 lamps, LED lamps, are in parallel as always. Let's see what the RPM is doing now. RPM is almost hitting 2000. Yes, 2000 RPM. 9 watt gives me 2000 RPM, and now the input is at 825 milliamp. So with the open coil it was 900, now it's 75 milliamp less, and also the voltage dropped from 20 to 19.8. Let me show you the light in the dark. I'm pretty impressed with the energy that is coming out of the two small coils. Not bad at all. Let me continue the testing. Now I'm gonna go for the DC side, and I'm gonna do first let me short the AC side. Not that it really matters. I'm shorting the AC side, as you can see over here. Shorting the coil, in my opinion, doesn't do me any good. And the RPM is increasing like crazy. 2030 and going up. Let me remove that. So shorted 2030, going up. Okay, now we're gonna go for the 0.6 watt load first on the DC side. Let's see what the RPM. Oh, let me show you the output on that light bulb is 5.9 volt DC at, yeah, yeah, let's say 80 milliamps. And the RPM should be decreasing because the AC load always makes the system speed up more than the DC load. RPM is 1960, pretty steady, pretty stable, yeah. So here is 1960 RPM. The output is 5.9 at 80 milliamps. 5.9 at 80 milliamps. Now I'm going to screw the second light bulb. As you can see, they are barely lit. Milliamps is about 110, and voltage, yeah, it is below 2.5 volt because this digital meter here always comes on at around 2.4 or 2.5 volt DC. So it is, yeah, let's say 110 milliamps. 110. Yeah, I'm not gonna write or measure the voltage here with the multimeter. It's not very important. RPM is 2005 and climbing. Now pretty stable at 2006. RPM was the 2006. Now I'm gonna go for this light over here. The holders for them finally come in the post, and that is absolutely awesome. Makes testing far more enjoyable. I will make a panel, like I make a panel here for the meters, also for all these lights. Let me unplug it here. I'm gonna put it over here, and we're gonna plug it over here. So in the first video, previous video on these coils, I had only one lamp and it was giving me around 11.78 at, if you can remember or go look at the video, 40 milliamps. Now I have two of them at 11.6 volt and they are giving me 80 milliamps. So yeah, not bad at all. But let's check the RPM now. RPM is 1915. It's still decreasing, so let's give it some more time. Output is 11.5 at 80 milliamps. Output is 11.5 at 80 milliamps. Let's wait for the RPM a little bit. In the meantime, I'll let you see the light in the door. These two lights, they are pretty bright, so very nice indeed. Trying to get them in my hand here, kind of slippery. Yeah, there you can see it. There's the pulse motor. Yeah, nice lights, very nice. The input is now at 19.9 volt DC and 875 DC. Sorry, 875 milliamps. The RPM. Hope you guys can see that. There's a little bit of a glare over here. Anyway, 1907. Yes. RPM is 1907. Open coil RPM was 1809 and 90, so it is still above that. Yeah, that baseline you can call that. Now I'm gonna go for the 5 watt load, which is a little bit crazy, of course, for these two small coils over here, but we're gonna test it anyway. Is it gonna be lit? No, I think, yeah, just a tiny. Hope you guys can. Yeah, can you guys see that? Yeah, I think you can see that. Just a tiny little bit. output milliamps is 110 and voltage, yeah, below 2.4 volts, as I said before. Now we are going to test, let me short the DC side. Shorting the DC side now. Put it here. Shorted milliamp is, yeah, also 110 milliamps. But shorting milliamps, you can't do anything with it, because like I said, you need voltage and amperage to do some work for you. And when the system is, when the coils or these coils are shorted, you get maximum speed on the load effect. 2020. It will climb a little bit more, but we'll keep it over there. 2020. Now I'm gonna fill this large capacitor, this one over here. I already written here because it takes a lot of time. When the capacitor reaches around 15.7 volts at 60 milliamps, at this point the RPM does go lower than the open coil RPM. Let me remove it over here. Gonna put these leads on the capacitor, one over there, the other one over here, and we're gonna put this one over here. It is beginning, it's coming on already. The blue LEDs are also coming here, coming to life. It is saying low. We're gonna wait for it. This capacitor is a 1 farad capacitor, automotive capacitor for a hi-fi stereo in your car. At this moment the RPM is higher, 1955, and decreasing. The reason it is decreasing is very simple. When the capacitor is empty, it draws the maximum amperage over here, milliamps. It's almost like a shorted system. That's why it has, the system has the most highest RPM. But the higher the voltage goes in the capacitor, the lower the milliamp goes, the lower also the RPM goes. And when this voltage here reach over around 15 and higher, it does goes below the starting RPM, which was 1819, and that is the RPM with an open coil, 1890. Let's check the RPM, what it is doing now. As you can see, it is still decreasing. 1905, 4, 3, 2, 1900, yes. Let's give it some more time. Here's a view of the two tiny coils spinning here. Very small. Here's my finger. As you can see, very small coils, like 3 to 4 centimeter, 1.5 inch. There they are. Input is now 20 at 900 milliamps, 20 volt DC. It has reached now 15 volts, so I'm pretty sure I'm gonna measure the RPM now. It will be below 1890. Well, they should. Let's see what it's saying. You can see that it is saying 1880 now. So filling a capacitor like this is the only time when the load, in this case the capacitor, makes the system go lower the startup or the RPM. We're gonna let it go for a little while. It is now at 15.98. Yeah, here it said 8, there's 9, so yeah, it's basically the same. Let's check the RPM now. 1874. 1873. It is now a 16 volt. Let me modify my own info over here. 16 volt, 0.1 at 60 milliamps, and the RPM was 1872. I've written the 1869, but it doesn't matter. 1872. So compare this RPM here with this one. There's a decrease in let me see here, 18 RPM. Other than that, I can put any kind of load on these coils and they won't slow down the system, only when using a capacitor. So it is a good test, because even though if you use a capacitor, you're gonna put a load on it anyway, so it will drop. So in other words, your system will stay in a RPM range above the start point RPM. Let me see here, I've shown everything, and as you can see, because the RPM is lower than the starting RPM, the voltage is 20.1 now at 900 milliamps. Show you one more time. These are the coils, pretty small coils, doing a pretty good job. Anyway, I remove that over here. I'm gonna put it one more time on these two over here, and the RPM should be climbing now again. 1890, that was the starting RPM. 1893, 94. Let's give it some time, because I written here 9307 RPM when these two are loaded. These two now at 11.5 at 80 milliamps. That's 11.5 at 80 milliamps is 0.9 watt, almost 1 watt, 0.92 watt. So it is double output, as you have seen in the previous video. So yeah, it is a good test. Let's check the RPM. 1903, 4, yeah, let's say 1903. So yeah, the only time the RPM is lower than the startup RPM is when I fill a large capacitor like this one, especially when you can fill it, but you have to fill it till a certain degree of voltage. Go above that and the system will slow down. Gonna show you one more time the lights in the dark. They are pretty awesome. Good lights, not bad at all. And as you can see, the input is wiggling about 20 volt DC and 19.9, and it is lower than 900 milliamps. It is now roughly 875 milliamps. So yeah, you can have some input, and the coils, the input, the load, I mean the load, the output will help the drive system to run a bit efficient. RPM is 1906 now, 5, 6, okay, 1904, 5. Okay, nice. In other words, a good test. What I'm gonna go do next, I have a lot of those coils, as you can see here. I don't know if they are all the same. I'm gonna make a half of a generator on one side only, and I'm gonna put let me think here, I think around 18 coils. The reason for that, for 18, is that when I put 18, there are always only 3 coils that are being energized at the same time, one and 120 degrees each. So that's a good balance for the motor, for the rotor, and also a good balance between the magnets on the rotor and the coils being energized. And hopefully, when I use that kind of system, it also reduces the drag the cores are giving me. Okay, I think I said more than enough. I think I showed everything I need to show. Give you a complete view of that wooden contraption over here. Yeah, you can see it all now. Input 20 volt DC. Yeah, or 19.9. 875 milliamps. When the coil is open, is the input 20 volt DC at 900 milliamp. So this load is helping out the motor side. Gonna disconnect everything. Now it keeps spinning away, even though I have the 2 cores, but the momentum in this large flywheel over here, this thing weighs around 20 kilos, which is around 44 pounds. So it has a lot of momentum. That's why it still keeps spinning away. I still have output and decreasing. Hope you enjoyed it. Thanks for watching.